Okay, I'm gonna describe this chart, which has a few roles. The first of which is to kind of show you what it means to start forming an ontology of something. In this case, I'm doing an ontology of knowledge actions. And then I'm going to show you kind of some concepts around how to modularize or categorize an ontology to show some of the structure at a higher level. So the argument is these two charts actually express the same concepts, even though they look quite different. This is the flattened chart, and down here is like the modularized chart that describes some concepts in the world of knowledge actions, but do so in different ways and have different kind of ideas. So okay, anyway, first of all, when you're forming an ontology, some people call these like mind maps, but basically I just started by thinking about, okay, I care about a knowledge store. And what are some examples of knowledge stores? Libraries, brains, and knowledge bases. And then I thought about, okay, well, what's the thing that each of these things kind of has in common? Well, they all store a type of knowledge. Now, this is oversimplifying things for sure, but when you talk about knowledge bases, like for instance, the Google Knowledge Graph, you think about storing triples. When you think about brains, you think about storing concepts. And when you think about libraries, you think about storing books. Now, obviously, brains store things besides concepts, memories, etc. Knowledge bases store things besides triple, like metadata, and libraries store things besides books, like magazines or microfiche or whatever, right? But anyway, the point is, I'm just kind of laying some concepts out to see what sorts of shapes I can make. And when I think about these three things, the book, concept, and triple, what I think is that this unit of knowledge is actually an example of each of those. And because the unit of knowledge is kind of the abstraction of those, we can think about the pure relationship between the unit of knowledge and the knowledge store. So the unit of knowledge is stored in the knowledge store. So now this part of the graph up here, so far, is basically saying that a unit of knowledge is stored in a knowledge store. A brain is an example of a knowledge store, and the unit of knowledge that is stored in the brain is a concept. Similarly, the library is a knowledge store. The book is stored in the library, the book being the unit of knowledge that is stored in the example of a knowledge store. And the same with triple and knowledge base. The triple is the unit of knowledge base is the knowledge store, and the way the unit of knowledge is stored in the knowledge store is the triple is stored in the knowledge base. Now finally, we can add a little bit down here where we start to think about a knower. And a person being an example of a knower, a person can create books and read books. And they can create and read books which are in the library. The person is the example of the knower. The way the knower relates to the unit of knowledge is that they create and consume the unit of knowledge. And the way they relate to the knowledge store is that they consume the knowledge store is consumed by the knower, and the knower contributes to the knowledge store. Okay, so that's kind of, if you can see, like this kind of lays out some of how these concepts are related to each other. You know, also a person has a brain. I added that one in there. So yeah, you could keep expanding this, but as you can see, it starts getting pretty complicated even with, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 concepts, and maybe 15 or 20 relations between them. It starts getting hard to understand what's going on here, or what's being expressed. Which brings us to the modularized or categorized version of this. Now, when we obviously, like, some things are missing here, like names of things, but basically what we see here is that each of these is that some of the kind of symmetry in this chart is being expressed explicitly here. So we have in the middle this kind of dense little graph of 3 nodes, which is that the knower creates units of knowledge, and units of knowledge are consumed by the knower. The knower contributes to the knowledge store, and the knowledge store is consumed by the knower, and the unit of knowledge is stored in the knowledge store. There's some small mistakes here. This consumed by should actually go the other way, because the knowledge store is consumed by the knower. So wait, let me... Yeah, like that. Okay, great. Anyway, and now what we see is in category theory called functorial projection, but basically just means you have these little graphs, like a concept stored in a brain, and you map the concept-brain relationship to its more abstract unit of knowledge store relationship. And then similarly, you map the triple knowledge-base relationship to the unit of knowledge store relationship. And similarly, you map this larger book-person-library relationship to this relationship. So to do this, to say, like, how is the person related to the library? You kind of follow the lines here to see what they are in this more abstract realm, and then you know a person contributes to a library, right? So even without the arrows in this diagram, if we just projected these onto here, we could see that if we make sure that each arrow here appears here, we get automatically the description of the relationship between these three things just by projecting these three, by saying the book is the unit of knowledge, the person is the knower, and the library is the knowledge store in this example. Now, of course, this, you can keep growing this, but the point of this is, look, this is really hard to kind of grow, because you just add a node and you add a bunch of lines, and the lines start kind of going everywhere, and it's hard to follow and hard to see. Here, each of these modules can be itself connected to other modules, right? So you're kind of up leveling. You're saying, like, okay, there's only really 4 things here. We can understand the internals of each of them, and then we can understand how they're related. So now we've reduced these 10 nodes to 4, basically. 4 with a few more arrows between them, because to map this into here, you need 3 arrows. Whereas to map this structure in here, actually, I guess you do need just as many arrows, because there are the arrows. Anyway, the maps between these nodes are bigger in a certain way. 2 arrows, 2 arrows, 3 arrows to relate this, and this is 3 arrows. But this reduces your number of nodes by 2. And the crazy thing is, as you build this out, you can actually start abstracting even these relationships and replace them by their own submodules to kind of keep everything clean in your knowledge representation. Because the whole thing about knowledge representations is it's easy to do small ones like this, right? This looks clean. You can understand this, how the knower, the knowledge store, and the unit of knowledge are all related. That's a very simple kind of little conceptual framework there. But as you grow this, it's going to get crazy. And in general, the biggest problem with knowledge bases is once you're talking about millions and billions of triples, the triple is the unit of knowledge of a knowledge base, for instance, the Google Knowledge Graph. Once you get to millions, billions, trillions of triples, how do you keep them all straight? How do you make sure that they're not talking about the same thing, that you don't have a duplicate triple somewhere, or that you don't have some sort of weird abstraction impedance mismatch? And to deal with those things at scale, you need to think about what abstractions can you build that allow you to deal with chunks of triples, chunks of conceptual relationships. Anyway, please leave questions in the comment section. I could talk more about this graph or draw this diagram or draw more diagrams if you're interested. So thank you for listening. Bye.